We have continuous function. To find absolute maximum, absolute minimum, we need to find critical points and the value for these critical points and endpoints, so for -1 and 3 of our function, and we have to choose the largest and the smallest values. So first, to find critical points, we need to find first derivative. So to find first derivative, I will change the square root to power form. H of z is equal z times 9 minus z squared to power 1/2. We will use product rule, so u times v prime is equal v times u prime plus u times v prime. In our case, u is equal z and v is equal 9 minus z squared to power 1/2. So h prime of z is equal, we have 9 minus z squared to power 1/2 times derivative of z is 1 plus, now we have to copy z times derivative of this whole expression, so we have to take down this power, so it will be 1/2 times 9 minus z squared to power 1/2 minus 1, and derivative of expression inside parentheses, so derivative of 9 is 0, minus, we have derivative of z squared is negative 2z. This is equal. So we will have 9 minus z squared to power 1/2 times 1 is the same expression, and here we can reduce 2, and we have z times z negative, it will be negative z squared times 9 minus z squared to power negative 1/2. So this is equal. We can factorize 9 minus z squared to power 1/2. In parentheses, we will have 1 minus z squared times 9 minus z squared to power negative 1. Why? Because when we multiply expression with the same base, we add exponents. So 1/2 plus negative 1 is negative 1/2. Exactly the same what we have at the beginning. So this is equal. We can rewrite, we have 9 minus z squared to power 1/2 times, in parentheses, we will have, because we have negative exponent, so it means we have to take this whole expression to denominator. So we have 1 minus z squared over 9 minus z squared to first power, so we don't have to write. So this is equal 9 minus z squared to 1/2 power, and in parentheses, because we have fraction, I will change this one to fraction too. So the same denominator will be 9 minus z squared, and here will be 9 minus z squared minus z squared. Close parentheses, this is equal. We have 9 minus z squared to power 1/2 times, we have 9 minus 2z squared over 9 minus z squared. So first, to find critical points, we will check the domain of our first derivative. Because we have fraction, we have to check the denominator. Denominator will be equal 0 for z equals positive or negative 3. But we see that negative 3 doesn't belong to our function. So only for f prime of 3 our derivative is not defined, is undefined. So it means doesn't exist. So for z equals 3 we have first critical point. Now we have to set our derivative equals 0. So h prime of z is equal 0 if and only if this whole expression will be 0. So we have 9 minus z squared to power 1/2 times 9 minus 2z square over 9 minus z square equals 0 when we have here multiplication. So when 9 minus z square to power 1/2 will be equals 0, or we have 9 minus 2z square over 9 minus z square will be equals 0. So I will take to second power both sides. So we have 9 minus z square equals 0. So z square is equal 9. So z is equal plus minus 3. Our interval is from -1 to 3. So it means -3 is not critical point. Only z equals 3. And we have to solve this equation because the denominator cannot be 0. So we have 9 minus 2z square is equal 0. I move -2z squared to the right side, so will be 9 is equal to z square. I will divide both sides by 2, so and I will change the sides, so will be z square is equal 9 over 2. So this is equal 4.5. Z is equal plus minus square root of 4.5. Now we can use calculator. So square root of 4.5 is equal 2.12 approximately. So this is equal plus minus 2.12. So we got three solutions for this equation. One is z equals 3, next is positive 2.12 and negative 2.12. Now we have to check if this values belongs to our interval. We have interval from -1 to 3, close interval from -1 to 3. It means 3 belongs, so we have first critical point, and from this equation only positive solution belongs to our interval, so we have z equals 2.12. So we have 3 critical points, but we see that this 3 is the same like we have before, so we have to use just one time this 3. So let's calculate value of our function h for these 2 critical points. So we have to find h of 3 and h of 2.12, and don't forget about our endpoints for our interval. We have -1 and 3. 3 we have, so we have to find the value only for -1. So h of -1. So now we have to replace z in our original function by 3 first. So we have 3 times square root of 9 minus 3 to second power. This is equal 3 times square root of 9 minus 9 is 0, so 3 times 0 is 0. Now we have to replace this by 2.12. So this is equal 2.12 times square root of 9 minus 2.12 to second power. This is equal, we can use calculator. So we have 2.12 times square root of, open parenthesis, 9 minus 2.12 to second power, close parenthesis. This is equal 4.49. We can write 4.5. And now we have to find the value for -1. So we have -1 times square root of 9 minus -1 to second power. This is equal -1 times square root of 9 minus 1 is 8. So we have negative value, and square root of 8 is 2.82 approximately. So we have -2.82. Now we have to choose the largest value, is 4.5. It will be our absolute maximum. And the smallest is -2.82. This is our absolute minimum. This is my solution.